ratios and proportions, right? So ratio is a comparison of two quantities by division, right? So anytime I'm dividing two things, we're talking about ratio. So you'll see them written a few different ways, right? One is just as a fraction, right? So A divided by B. The most common way you'll see it, though, is with that colon in between, right? A to B. That's what we're talking about. And sometimes they'll write it out, right? And say A to B. So whatever A is to whatever B is. So this second way, right, this is going to be your most common way, and that's how we're going to write them when we write ratios. So look at a couple different examples, right? So first one, it's looking at if a bald bonsai cypress tree is 15 inches tall, right? And the actual tree is 118 feet. What's the ratio of the height of the small tree to the height of the large tree? So first thing first is whenever we write ratios, the measurements that I'm using, whatever they are, they need to be in the same unit.
It's finally not often good.
Nope. So if I look, right, small tree is 15 inches. Large tree is 118 feet. So now when I look at this, right, I need to make a decision on what I'm going to convert, whether it's inches to feet or feet to inches, so that I can have the same unit. So when you go to look at this, what I would recommend is look at, is there one that you can convert that won't give you a decimal? Right? So if I converted 15 inches to feet, would I get a whole number of feet? No, right? I'd get a foot and 3 inches. Right. How about if I convert feet to inches, though? Yeah, how do I do that? So I'm going to times by 12, right? So that would give me that is 1,416 inches tall. Right, so now I have the 2 inches that I can, two sets of measurements that I can use. So the key here, when I talk about writing this, is the way it's written out, right? Ratio of the height of the small tree to the height of the large tree. So when I go to do this, right, I'm going to start with the small tree, right? So 15 is what I know. I'm going to do my ratio symbol there to the height of the large tree. Okay? And so now when I go to look at this, I need to reduce this, right? So just like you would reduce a fraction, gentlemen, I'm going to reduce this. So I want to check, does 15 go into 1,416? Right? So if you were to do that, if you do 1416 divided by 15, you get some decimal. So that one doesn't work, right? So to look at, is 5 going to go into 1,416? No, right? Because it's not a 5 or a 0. So I'm going to check, what's the next highest factor of 15? 3. So if I do 1416 divided by 3, I get 472. Right? So I can divide both these things by 3. And so I get 5 to 472. Right? That's going to be the final answer. That's how a multiple choice question will write it. They'll reduce it down to the lowest that they can. Right? So basically what that means is that for every 5 inches on the small tree, right, corresponding length on the actual tree would be 472 inches tall. Okay? Questions on that? All right, so sometimes we'll look at and we'll have a ratio and we'll have to use them. So one thing I want you to do is my little ratio symbol disappeared somehow, so that should be 2 to 3, not 23. All right, so here we're talking about selling tulips to daffodils, right? Ratio of tulip pots to daffodil pots will be 2 to 3. And they're going to buy 120 total pots. So I need to figure out how much of each are they going to buy. So I know that I have 2 tulips for every 3 daffodils. right? Or there's 3 daffodils for every 2 tulips. But that's the reduced version of the ratio. So I need to think about how do I figure out what the actual thing is, right? So if I think about that example above, I divided both by 3. So if I wanted to figure out what the actual height was, right, I would need to multiply by 3. So when I look at this, I can say, well, that number that I divided out to get 2 and 3 was the same thing. So if I multiplied those back by that number, I would get the total. All right, so now I need to set up an equation. 2x plus 3x is going to equal the total number of plants sold. And now I just have an equation that I can solve. Right, 5x equals 120. So x is equal to 24. All right, so if I want to know how many tulips did they buy if x is 24?
48.
48 tulips. Right, and then how many daffodils?
72.
72. Okay, so here's how I'm kind of using a ratio with 2.
Dang, you did that.
All right, so extended ratios, right? So these are ratios that compare 3 or more numbers. So I have A to B to C, right? Which is basically saying that A is A to B, B to C, and A to C are all individual ratios in there. So they tell me here that the side lengths of the triangle are in the ratio 3 to 5 to 6, and the perimeter is 98. Right? And what's the length of the short side? So here's where, right, we're still going to draw a picture because I want to label some stuff and see what I'm looking at. So if they tell me that the side lengths are 3 to 5 to 6, does that mean their side lengths are 3, 5, and 6? No, that means I divided out the same number from each of them, right? Because I don't know what that number is, to kind of undo that division, I'm going to multiply it back in, right? So 3x, 6x, and 5x are the lengths of those sides. So the question is, how do I find the length of the shortest side? I have to set up an equation. So they tell me the perimeter is 98. What do I know perimeter is?
Base outside, height outside.
What do you mean by the outside, Braden? So it's the outside all added together, right? So it's the distance around a shape. So if I know that that's it, right? I have 3x plus 5x plus 6x equals 98. So end up with 14x equals 98. So x equals 7. So now x equals 7. So now you look and say, Ty, what is the length of my short side?
Short side? What's 21?
What?
21.
Yeah, right? I just plug that back in and say 3 times 7. So the short leg is 21. All right, so proportions, right, are an equation that states that 2 ratios are equal. Right? So if I said 2 ratios are equal, like if I said A to B was equal to C to D, that's not something that I know how to solve. Right? But I can set it up as an equation and say, well, if I know that a ratio can be written as a fraction, right? So A divided by B, I can write these both as fractions and then just set them equal to each other. So now I've got an equation, right, with a fraction equal to a fraction. Almost done. So if you remember back from probably middle school, right, we talked about how do we solve this type of equation, right? Is that cross products property? Say that that is the same thing as A times D is equal to B times C, right? We're going to use that kind of idea of cross multiplication. So we're gonna look at a couple of examples here, right? So if I do like cross products, right, take 5 and x, multiply those, 6 and 4, multiply those, so you get 5x equals 24.
You can go in 6 and
Probably, yeah. So divide by 5, you should get 4.8. Right, so all we're doing here is just solving these equations. Right, because this will come up when I start finding missing side lengths tomorrow and Wednesday. Okay. All right, so we'll do the same thing over here, right? So 9y is equal to, now anytime you multiply where you have two terms, right? You need to make sure that you put that in parentheses.
Wait, why?
So you can distribute.
We can't just do it, like, doing it there?
You can. Yeah, if you want to, you can.
Oh, so we don't have to.
You did parentheses, you just didn't write them down.
Okay, so like, if we take quiz over that, would that make us lose half a point?
No. So I'm going to distribute that. All right, so 9y equals 3y plus 12. All right, so now I have an equation that I can solve. Subtract 3y, so we get 6y equals 12. Y is equal to 2.